First up, we have Turbonomic, and June is going to walk us through how Turbonomic is using KCP-Edge.
Okay, thank you, Andy. In this chart, it shows the use case where KCP-Edge and Turbonomic together optimize the workload placement problem on the edge clusters. In this chart, we can see the blue boxes in the bottom representing the edge clusters. And on the left-hand side, in the gray box, we have KCP-Edge components, which are just introduced by Mike and bootstrapped by the automation created by Braulio. On the right-hand side, we have two green boxes. Those are Turbonomic components, including the Turbo services running in the center, as well as the KubeTurbo, which is the agent running in each of the edge clusters. We are using GitOps in this work, so we have a Git repository at the top, which holds the configurations used in this work. And we can use our favorite CD tools. In our case, we use Argo to deliver the configurations from Git repo to the workload management workspace, WMW, of KCP-Edge. All these moving parts altogether forms a closed loop optimization for the placement problems. Where the Turbonomic plays the role of the brain to make placement decisions and write that decision to Git. And on the other hand, KCP-Edge plays the role of the actuator, which execute those placement decisions. That's the overview of this piece of work. Now let me hand over to Chalk to talk more about Turbonomic as well as a recorded demo for more details.
Thank you, Jun. So let me share now and show you a demo of the prototype. Tab share. We move applications across multiple edge clusters to balance their actual resource consumptions. And this is the same demo that we did last December, and just replacing kits with KCP-Edge to work with Turbonomic. So, let me play. So here on the right, we see we got two client clusters. So for KCP-Edge, we deploying the Turbonomic agent called QTurbo onto each clusters. The agent collects and sends topology. The server turns it into a supply chain that you see on the left. Turbonomic takes a unique approach of modeling the entire topology as an economy of traders buying and selling commodities. And you see from top down here, application consumes resource commodities from containers, and container consumed from virtual machines. And then Turbonomic applies economic principles to work out the best, the optimum resource allocation continuously. So now let's look at a simple example of these two clusters, the two edge clusters. One has a high CPU low and one is very low, and they are very imbalanced. CPU, just one example. As you can imagine, Turbonomic takes into consideration multiple resource dimensions, even including energy, carbon footprint, and perhaps anything you can bring into the model for Turbonomic to continuously work out the optimization. Let's see what we get here. So there are resized actions. Turbonomic observes CPU filtering on some containers and recommends to size up the CPU limit to alleviate the unnecessary filtering, which would otherwise impact your performance. But for this demo, though, we will focus on the move action that recommends to move an application from cluster 1 to cluster 2. And as you can imagine, that would make the two clusters more balanced in terms of their CPU loads. And if you click on the details, and it will tell you, estimate that, indeed, that after the action, that they estimate that they are more balanced. So now let's execute the action. So the execution, like Jun described, through some Git route integration, which means we're going to generate a pull request And to change the, so when we get there, they will change the KCP-Edge MC placement and change for this application from placing IO1 to IO2. So IO here actually means cluster, so those two edge clusters. And so that means that we're replacing it to cluster 1 to cluster 2. All right, so let's actually merge the PR and to execute the action. And before we merge, let me show you indeed that we have the application running on cluster 1 on the top and not on the cluster 2 on the bottom. So now let's confirm the merge, which actually through GitLab will execute the action through KCP-Edge, the syncer and everything. Now you will see that the application is being terminated on cluster 1 and started on cluster 2.